recording it then.
Yeah, we will do it for you. Don't worry about it. All right, I think we can get started. I think people will like coming in gradually. So, hey, welcome everybody. We didn't host these WebHack meetup last month, and due to most of our organizers are pretty busy last month, and so we didn't find a speaker to do so. So it's been a while. And today our topic is about gRPC and Protobuf, and we are honored to invite Stan to be our speaker. And here are our schedule. We will have a quick introduction for WebHack meetup, and then we'll hand over to Sam to talk about gRPC and Protobuf. And after that, we'll have like around 10 to 20 minutes Q&A. And at the end, we have like free-form networking. So quick introduction of WebHack meetup. We've been doing this meetup for over 5 years. And we've been hosted like over 50 events in Tokyo. Before the pandemic, we used to host these events in different offices in some like big tech companies in Tokyo. And after pandemic, I think we are one of the early mover to move these events online. And we even created our own YouTube channel. So if you haven't subscribed to our channels, you can search for WebHack Meetup on YouTube and check all our past videos to learn some knowledge. And so far, we have more than 2,000 attendances, and in our community, we have more than 1,500 members. And if you already joined a lot of our events and haven't given a talk in WebHack Meetup, I think it's time for you. You can check the link, talk at WebHack, and you can submit a form or contact any of us that will reach to you. All right. Let me quickly introduce today's speaker, Stan. Stan is actually my colleague in DoorDash. We are a food delivery company based in San Francisco. And Stan is one of the all-rounder engineers in my team. And he mainly specializes in mobile development, but also doing front-end development or back-end development, everything you name it. And he are also one of the most cutting-edge guy who always have many cool tech toys. So during the networking time, feel free to ask questions to Stan or talk to him. Without further ado, Sam, let's welcome Sam to the stage. Can you take it over?
Cool, yeah. All right, let me share my screen. And let's start. All right, good to meet everyone. My name is Sen Zahid. I'm a software engineer at DoorDash/Wolt. I'm fairly new to Japan. I moved to Japan about 2 months ago, but I've been working at DoorDash for a little under 3 years now. So I joined DoorDash at a very interesting time where we had just begun migrating away from a monolith to a microservice architecture. I primarily worked as a mobile engineer there, but in my career so far, I've done a little bit of everything, including backend. But the backend that I'd worked on was generally monolithic backend. So when all this microservice stuff started to happen, it was really a trip to try to understand how all these things were working together. And there's a lot of concepts that I'd heard about before a little bit, but I didn't quite understand. So today we're going to go through those and give some very basic examples and try to develop a basic understanding of what gRPC and Protobuf are, why they're useful, and what it looks like when they get implemented. So in the beginning, when a software project or a company starts, things start out fairly simple. There's usually very few repositories, you have small teams, your goals are going to be fairly clear. There's not a ton of complexity, and a lot of the decisions that need to get made can easily be made over a Zoom call or over a meeting over a desk. But then things start to grow. You start to add more and more features, you need more and more APIs, your mobile clients or your web clients are going to become more complicated. They're going to need more data and different varieties of data from the back end. And then more users join. And those users have different needs and might need new things. And then your teams at your company are likely going to split into sub-teams. So instead of just having one big backend team, your teams might separate by what feature that they're working on. And then when this happens, making decisions about what direction the project should take can become more complicated. That is, the team has to agree on a lot of things. Uh, the decisions that get made early on end up sticking with you. And even if those might not be the best decisions for every part of the business or every part of your application, you're basically stuck with them. And if one part of your application needs to change in a certain way, you have to really adapt everything else to change as well, or certain changes just never happen because it would be too big of a move for everyone to adapt as well. And if you get really lucky, then your project might get massive. You might get more and more users that need more and more data across your services, and more engineers are going to be working on the same project. And then you're going to need the infrastructure, both in terms of infrastructure for your developers to build stuff together, and also for the users that are trying to use it in terms of like deploying things to a backend and making sure that your services are available. Now, if you start small and you end up getting a lot of users, a lot like DoorDash did, you end up kind of suffering from success. The more people you have working on the same piece of software and the higher the complexity of that software, the bigger the risk that things are going to break. When you have 100 engineers, let's say, working on the same monolithic backend code, there's more room for errors. And the problem is you have a lot less flexibility when scaling. And you have a lot less room for errors. So if one feature breaks, that means that that instance of your server is broken, right? It's not such that if one feature stops working, that everything else can keep on going. If a minor feature crashes your application, the entire application has crashed. And if that feature is crashing on everything, then your entire service is down. And that's not a place that anyone wants to be. And then likewise, when it comes to scaling, you can't give resources to the specific parts of your application that demand more resources. In addition to that, the safety measures that you have to put in place to avoid things breaking end up getting in the way of developing things quickly. There ends up becoming a lot of red tape. Because any small change could bring everything down, a company ends up needing to add a lot of red tape to approve changes. And then still the issue with every team having to use the same tool set, the same frameworks exists as well. So the obvious solution to this is to break things into microservices. So different parts of your application can live in different applications altogether. So, at DoorDash, we have separate services for the menu versus for ordering, for example. And the idea is that you can also separate out your databases. So a microservice can own the data that it's responsible for distributing. So you can start to not worry so much about two services trying to write to the same database at the same time and things like that. And then you can also scale features up or down as you need them. If one part of your application doesn't need that many resources compared to another, you can simply scale one up and then leave the other one alone. And the other big advantage to microservices is that each service doesn't have to be running on the exact same framework or tools or even language. So teams are able to make more autonomous decisions about their code without necessarily stepping on other people's toes. And then the failure problem also gets helped out here because if one service fails, if it's not essential, it doesn't necessarily bring everything down. So it's easier to have graceful failovers and to have a happy path that you need to make sure is super reliable, and to have auxiliary services where if something goes down, you're not completely out of luck. However, this comes with its own set of challenges as well. Now that not everyone is working on the same code, we need to coordinate between these services. Microservices will have to rely on each other, and you have to worry about dependency graphs. Managing dependencies becomes important, like who's able to call whom. And then it goes from really building a monolithic tower to more like running a kitchen with line cooks, having to decide where to put the ingredients, who's in charge of getting what ingredient, and trying to put everything together to be able to serve things out to people in the restaurant. So inter-service communication becomes crucial. So how do services talk to each other? A naive approach might be just to use REST, since that's what we already use for our server and our client to communicate with each other. But this is basically like having a ton more client-server pairs between every pair of services. So now you have to come up with names for your API routes. You have to make sure that everyone consuming a service knows what that route URL is and types it out correctly and adds the correct query parameters or the correct body and everything. And you can do that with API contracts, but you end up having a mess of API contracts everywhere. So discoverability becomes an issue. And God forbid, if an API changes and you have to version it, then you have to worry about developers being on an old version, having to convince them to migrate to a new version. And when you have a lot of different services, just the effort that it takes to get everyone on the same page is like a full-time job in itself. So a workable solution for us is gRPC. gRPC was developed by Google in 2016, and it's now run by the Cloud Native Computing Foundation. The G in gRPC doesn't stand for Google, it stands for gRPC. So gRPC stands for gRPC Remote Procedure Call. And this basically takes the place of the HTTP library that you would use in your code. So when you're doing REST, you need some way to make HTTP calls. And you're generally going to be using a library for that, or maybe using built-in standard functions to do that, although that's generally a lot more painful. The point of gRPC is, instead of getting a library that someone else is going to have to support and fix errors in, and then using that to set a URL and fire off requests, you use gRPC and you make it aware of your services so that you're not just typing in a route and hoping for the best, but everyone who's consuming and serving data knows what's going on without having to set up these routes and make everyone aware of them. So the way that this works is that we have to define everything first. And we do this using a language called Protobuf, or protocol buffers. This is also designed by Google, and this is kind of like XML or JSON, but when we send it over the wire, we send it in binary, which makes it a lot faster. So you set this up with messages, which define your objects, and you can nest them, you can create structs, you can create new types, so on and so forth. There's a bunch of pre-created types from Google for things like timestamps. And everything in your microservice architecture can become aware of what these types are. So it's not so much here's a contract and then go create an object in your language using this, but everything knows what's going on in those microservices. And these types are then used to generate types in the respective languages of your services. So these are kind of like inter-language objects that are sent in binary, and they're turned back into native objects when you receive them. So it's a lot like when you, if you have a Java server communicating with a Node server with REST, you have to turn everything into JSON, serialize it, deserialize it. This basically makes it a lot easier to treat them like they're just native objects coming over the wire. So here's what it kind of looks like. This is what it looks like to create an object using one of those protocol buffer definitions. This gives you type safety. So because it's Codegen creating these, if you said something was an int, it's very clear that it's an int. The builder will have the int type, and the generated code makes it a lot easier to know what you're working with. And whether you're using Python or Java or Kotlin or even like C++, everyone has a shared source of truth for what your objects are, what they look like, and how to build them, which makes it a lot easier to use whatever tools you want and still have interoperability. So let's say we've defined all of our objects that we're going to work with for our application. Next, we have to define what our services are. And we create a shared map of the territory. So these are just some examples from just the main docs page for gRPC. Here we have a service called Greeter. Now, services contain RPCs. RPCs are kind of like functions, but they're what you would be replacing your API calls with if you were using REST. So it's a shared contract for APIs. We don't need to set routes. Everyone has access to these proto files. The server knows, hey, I have an RPC called say hello. Here's what the request looks like. Here's what the response should look like. And then we define what each of those objects look like in a way that both the client and the server can understand. So we create a shared map for our territory. We define what the service is responsible for, and we define its inputs and outputs for everyone to see. Now, on the service, here's what we do. We pick a language. You can use basically any modern language that you want to use, and we can generate the code to implement gRPC. And in some languages like Node, this can be done dynamically. You just give it your file path to your proto files, and at runtime, it'll generate the class for gRPC. And for other languages like Kotlin, you actually statically generate these, and then you can import them into your code, and you have access to all the types that you can just use as though they were native types. And it ends up becoming simple as having an interface and filling it out and then running that on your server. So it looks kind of like this for Node. For Codegen, this is dynamic. So you set up your directory for your protos, you load gRPC, you load your protos, and then you say, hey, here is options regarding how I want to process these protos. You set up the descriptors, and then you get a basically a guide for here's what services are available. So this makes your Node server aware of what's available and what it's able to do, or what it's responsible for doing, rather. Then when you implement the service, now you just set up the functions that correlate to the RPCs that you define in your protobufs. And just like anything else, you spin up a server, you add the service to it, and then you open up the port. You can set authentication if you need to, and then you just start your server. You can see here that it's just like defining functions. You define a function here and you call the function over there. It takes a lot of the work of coordinating routes and REST API contracts out of the picture. Everyone's running from the same understanding of what these functions are and how to call them natively to their code. So that's how you do it in Node. In Python, here's what it looks like. In Python, it's going to be static. So in Python, you actually have to run a command here that will take your proto file and it'll generate Python files for you that you can then import into your code, and then you can begin to implement them, or if you need to, you can consume those services. So in Python, here's what implementation looks like. Again, it's fairly straightforward. You've already defined what the method names are. You've defined what the request and responses look like. And because we have the Codegen, we have functions that help us to create the relevant objects for a given service based on the protobuf. So we have our hello requests and hello replies. We have a function that creates them. Fairly straightforward. And then for Python, once we're ready to serve our server, here's what that looks like. Again, fairly simple. We create a server. We say, hey, add this service to it. And then we tell it what port to run on, and then we start. So you can have more than one service on your Python server if you wanted to. You can separate services based on whatever makes the most sense. So if you have one Kotlin server that's responsible for 3 different things, you can create 3 separate services if you want to keep those things clean, or separate out responsibility, even to sub-teams that work on the same microservice. So there's a lot of flexibility in how we set things up. But at every level, we know that someone is responsible for implementing the method, and we know that if the protobuf says the method exists, we should be able to call it, and we should be able to get our data. On the consumer, it's fairly simple as well. We pick a language. You can use whatever protobuf supports, all the modern languages. We generate our client code, and then we define the server address, because just like GraphQL or anything else, we need to know where the server is so we can send requests to it. Just an IP address, right? Some way to know, hey, here's where I send my requests out to. We get a stub client that gets generated from the gRPC code, and we can just call those functions. And it's as close as you can get to calling a function and getting an answer. It's just happening over the network. So very much remote procedure calls. So here's what consuming those services can look like. So this is in Node, just to add some variety there. We set up a client. We say, hey, here's the service, which is greeter. Here's the address it should be at, and then we give it credentials if we need to. And then we just call client dot the method that we want to call, and we get our answer. It's fairly simple. And if the data is sent correctly from the side, from the server, you're going to get the data correctly on your client side. Everything ends up being fairly in sync. And if you're ever unsure about something, you can always take a look at the protobuf files, which are human readable, and double check anything that you need to double check. here's what it would look like in Kotlin. In Kotlin, it's more of a statically typed language compared to something like Python. We have to create a channel, and the channel is what defines the address and the port of our gRPC server. And then we create a client class that's able to call these. We give it the channel, and then we're able to get a stub, and then we call the methods on the stub like we would call methods on any other class, and then we get our responses, and we're happy. And then we can close the channel whenever we want to close the channel. So there's a couple of niceties that come along with using gRPC. There's no route names to decide. The function names are what they are. You can see exactly what they're going to return and what they can take in. If there are new protos that get added to your Protobuf code base, you can just regenerate your clients. Now you have access to all those new functions. And protos can get as complicated as you need them to be. You can define structs, you can define your message types, you can use your custom message types inside of other structs. The fact that they're sent in binary means that everything's going to be very small, unlike with something like JSON or, God forbid, XML, where it's intended to be human readable as it's going over the wire. There's no such requirement for Protobuf. So things can get pretty fast just natively. So even with JSON, you can gzip it and you can compress it. But this comes as first-class functionality just by the nature of how gRPC works. And then when it comes to load balancing, it's fairly simple as well. If you just point your gRPC address to a load balancer, you can have several instances of your server running, and you can distribute requests as you need them to be distributed. So it's fairly easy to start load balancing and scale things up or down as you need to, and still on the client feel like you're just calling a function and getting a response. gRPC also supports streams, both one-way and bidirectional streams. So if you needed to stream data between your services, you would be able to do that. And because it's using HTTP2 under the hood, you're able to send requests over the same connection. So you can multiplex connections. So that is the very very basic intro. If you're interested in learning more about it, the grpc.io/docs is a great place to get started. There's API documentation, quick start guides for all the different languages that are supported there. There's a protocol buffers page, which is also very useful to look at to see what the syntax looks like, how to create custom types, and all the intricacies of Protobuf. And then there's a GitHub for awesome gRPC, which contains just a massive list of libraries and links that can help you to write your projects in gRPC. All right, and that is everything from me. Thank you and good luck.
Yeah, thank you, Sam. Thanks for your nice introduction to gRPC and Protobuf. And I think now it's time for some questions.
All right.
Any questions you guys want to ask? You can ask directly, jump to the stage, or you can ask in the chat.
How does retries work? Like, so in case of HTTP, we can have mechanisms of exponential retries or anything like that, right? So when two microservices are communicating with each other, so if the request fails, then how does the retries work in gRPC?
Let's see. With gRPC, you can define error types, so you can see when an error comes down, and then you could do retries that way. I think there might be native support for retries on gRPC as well. I'd take a look into the docs for that.
Thanks.
Okay, we got a question from Shiting. Neil?
Yeah. Thanks for the great talk. I might be confused, but I'm wondering how the API versioning will be looking like. For example, if we want to change the footprint of a single RPC, how do we do the version control?
Sure. So the way it can work is that when you define your separate services, you can define a version number for that service, and then as the protobuf changes, you can increment that version number. The way that another thing that you're able to do is because what your clients are ultimately going to be using is the generated client code, you can package that client code into its own library and then publish that. So what you can do, and the way that we do it at DoorDash is you can set up a CI process on your Protobuf files to just generate that client library, and then have that client library be a dependency for your microservices. So if a protocol buffer changes, it can publish a new version of your client generated package, and then your client can update your version in npm or in Gradle or whatever, and you've got the new version of the client there. In terms of backwards compatibility for versioning, so long as you don't change the types, you get backward compatibility by default. So if you add new types in, then you're completely fine. If you change something that's not being used anywhere, that's like a shaky thing when you've got a ton of engineers. But you're able to make non-breaking changes and publish new versions of the client and consume them, and that works out fine.
Sounds great. Thank you.
Yeah, we got another question from Idle.
Hi, yeah. Nice talk. So everybody that's probably developed with REST probably uses for debugging and all that, probably use like Postman or Insomnia, and like to generate documentation, they probably use Swagger's tools. I'm pretty sure that Postman and Insomnia support gRPC, but would you recommend tools other than, what the usual REST developer would use, like to generate and debug for gRPC based applications other than the usual suspects?
Yeah, that's a good question. The one that I personally use is called Bloom RPC. It's fairly straightforward, minimal frills. It's just you import your proto files and then you point it to a server, and you can set some headers if you want to for authentication, and you can just fire off requests and stuff.
Did you say Blue as in BLUE RPC?
Oh, BLOOM.
BLOO, Bloom. Okay, got it.
So Bloom RPC is one. There's a new one called Freya, FREYA. I haven't had luck getting that all set up though. There's like a bunch more steps to the way that it's a lot more complicated. But I imagine that the complexity probably helps you debug a little bit more. But I would take a look at Bloom RPC for simplicity, and then Freya for more features.
In your opinion, are those tools like better to use for gRPC than, for example, like Postman or Insomnia?
I haven't used Postman so far for gRPC.
Okay.
But we generally just use Bloom RPC, and that hasn't failed me so far to go find an alternative so far.
Okay. I actually, I don't even know if Postman supports gRPC. I'm assuming it does.
I think it does. I think they added it fairly recently. It wasn't there from the start, but they added some support for it. The Postman is very much just like REST first. So some of the tools that are kind of RPC first are just built from the ground up for it.
Because so obviously you said that the big advantage of gRPC is speed because it's binary and all that, and I get that and all that, but a common complaint with developers is that the human friendly human readable format of REST and all that makes it easier for debugging and development. But yeah.
There's something to be said for that. But I think that, the point of the API contract is you're hoping that people will follow it, right? And I think that the fact that you're going to be generating code and all the types are already there takes away at least some of, the point of having those contracts. I worked at places with a lot of REST where there's a bunch of contracts and they're almost always like out of date, right? So to have something that's generated and that's guaranteed to be at least consistent with what's published, I think is I would rather take that than having something human readable that may not actually be implemented the way that it says that it is. But it's definitely a trade-off, and there's got to be like RPC tools to generate documentation like that. I wouldn't be surprised if there are. I haven't come across them so far. I just haven't needed to use them. I'm primarily a mobile developer. This is kind of my initial foray into RPC. I'm sure that there's documentation generating tools out there, though.
If nobody else has another question, I got another question, but I'll let somebody else have a turn. But yeah.
Cool. In this case, then we got one from the chat. Ellen asking if there are two services two services using gRPC to communicate. And if one service didn't send a request for like longer than 2 or 3 minutes, and it seems something will go wrong to gRPC. Do you have any similar experience?
So there are timeouts and deadlines that you can set. So there's one thing like opening a connection, and I guess like if you don't set any timeouts or you set like a ridiculously long one, you're just kind of going to be waiting. And with REST, I know that there's generally like some timeout that's going to be like if you don't get the data back to the client within a certain amount of time, the connection is going to close out. There are if you expect that you're going to have delays for like 2 to 3 minutes, you could probably use streams for that, which are meant for kind of keeping a connection open and then sending down data whenever you have it. But otherwise, for the unary requests, you can use deadlines for here's the time by which this has to complete, or you can use timeouts for like, hey, if I'm waiting this long and nothing's happened, close the connection. So a lot of that is configurable.
Cool. Alan, does he? Yeah, sounds good. Any other questions?
Ido had another one? Yeah.
Yeah, go ahead.
Yeah, sure. Sorry to hog all your time. So obviously things, all of the big major cloud providers like AWS, GCP, and Azure all do gRPC and a lot of their services they provide. But like, for example, I know from GCP, for example, it's a thing called Cloud Endpoints, I think. I think it has a service which allows for transcoding, like HTTP JSON to gRPC or like REST gRPC and all that. Have you used any of that? And if not, or if you have, are there any pros and cons to using those type? I guess they're not called proxies. I don't know what they're called, but you get my drift. They convert between one format to the other so that you don't have to re-encode your servers or anything.
We haven't used that here. In fact, over at DoorDash, it's a huge effort. It was to go from kind of the monolithic thing to all these separate microservices. So we just put in the work to do the migrations. I'm sure there's probably some thought put into whether or not to use those services. I wasn't part of those discussions. I came in kind of right as stuff was like, we had the microservices, now we're migrating everything over to them. So I'm not 100% sure. I'm sure there's some use cases for that though, but it's probably a very team dependent thing.
Because what I'm thinking is like, let's say you have a a legacy mobile app out there, and up until point of time it's probably REST, and then you want to go to gRPC. But obviously there's going to be some of your users that are going to hold on to the old app for as long as possible for human existence. So if you like have an existing microservice or monolithic architecture that was originally REST RPC, and then you want to convert to gRPC for performance, you might either have to you probably have to support both interfaces for a length of time. Until you're convinced like 99 point whatever percent of all your customers are using clients that can support the new one. So I imagine that's where it would come in handy.
Yeah, so I can imagine that being useful. I think that generally the use case that gRPC pitches itself for is more just for communication between your servers, not so much between your servers and the end user client. Like, it doesn't support things like the browser out of the box. Where it comes to like using generated code like that in like a mobile application that's like using REST, I have some experience with like GraphQL, using GraphQL on like a mobile client, and similar to the way that gRPC is here on the server, GraphQL could generate classes for you to use on your mobile client. But kind of like what you're saying, then if there's a change, then you've got to change everything on a mobile client. That's like you have to do an app cycle and wait for reviews on iOS and everything. It becomes a bit of a headache. So I personally am not super big into Codegen, like GraphQL or gRPC on like client side, like end user client side. But the benefit of using it on between your servers is that you're in control of letting things be outdated or putting new things up or deploying new versions of it on there. So it makes it a lot easier. But if you did want to use it on a client, then I agree. Like that would be that wouldn't be the worst use case. I'm sure there are trade-offs, though. I haven't tried it out, but it's worth looking into for supporting legacy applications and trying to get the speed benefits. Okay, there's a question about the status codes. So yes, so that's a good question. There are separate gRPC status codes. They're generally like small numbers, so it's not like 100 or 200. It's like 7 or 2, and they can refer to. I think 2 is like the service that you're trying to call hasn't had that RPC implemented on it. So like if you're calling an RPC on the wrong server, you might get that status code for like it's not implemented. There's others for like authentication, very similar to what your HTTP status codes are going to be. There's generally an equivalent to those in gRPC status codes.
So for HTTP status code, like people are talking about, many people misuse those status code. And in gRPC, do you have like same kind of problem, or it will be more stricter when you define those?
So far, I haven't actually needed to define a status code. It just kind of comes with a package. Like it so far, the status codes that I've encountered have been more about the gRPC kind of client running itself rather than about anything specific to my service. So you just kind of get the status code that you get. I'm sure there's ways to send down specific status codes, but so far in my development with gRPC, I just haven't needed that. Like if it's not authenticated, then I get a not authenticated. If the thing that I want isn't there, I get that, the data is not there. And it works out fine. So the potential for misuse is definitely there if you can, set different status codes, but wherever there's a status code, I think the potential for misuse is going to be there.
Got it. Sounds good.
Yeah.
Got another interesting questions about, have you experienced issues with supporting null values?
Yeah, that's the thing. I think that there's, with null values and things like optionals, that's one of those places where it's like super important to not just for the service to know what you're working with, but for you to know what you're working with. For a language like Kotlin, you have the idea of optionals and you can see when something might be nullable. And then for things like Java, I haven't used gRPC directly with Java, but there's got to be some way to add nullable wrappers to things. Like I wouldn't be surprised if there's just some way to add nullability wrappers on top of statically typed languages that, or languages that don't have like nullables in them. But at DoorDash, we generally just use Kotlin, which has optionals kind of as first-class citizens. So you're able to at least do some null checking while you're working with those. And the protocol buffers themselves have some notion of optionality there as well. What I have had more trouble with is not so much null values, but empty values. If you just have a value and it's empty, and then you reserialize an object on the other side, if you have generated properties that are based off of that value, and you're expecting that if it's not null, it's also not going to be empty, that's when I've run into some issues where, I send down a value as empty and I think it's fine, but then on the client side, they're taking that type and then adding a bunch of computed properties on top of it, or wrapping it and adding computed properties, and they're expecting for the value to be not empty. So I've had more issues with values being empty but not null than I have with values being null, because it's easy to just do a null check on something like Kotlin. I think you're muted.
Oh, yeah.
Okay, there.
Thank you. Yeah, Leon, that's you. Yeah, cool. Any other questions? Yeah, I also got one. Like, you mentioned about you started when you joined DoorDash, you started doing this kind of migration from monolithic to microservice, right? And during this migration, did you encounter any like difficulties, or what's the main challenge?
I should clarify. The migrations that I was doing as part of that was more about making the mobile client work with the microservices, not so much, building microservices themselves. I started working on backend at DoorDash after a lot of those migrations and extractions had already happened. So I started building stuff on top of the backend that had already been built out. So I had experience there. So when I started working on backend and working on gRPC there, a lot of the stuff had already been set up. So it wasn't so much doing the migrations and the extractions, but more so adapting the mobile clients to use those. And that there's ways to make that less painful. So if you have stuff using REST before, or you have a monolith that you're calling directly, you can set up a gateway in between and then do forwarding if you really need to. So you can have your URL not hit a monolith, but hit a gateway. So your client hits a gateway. The gateway can then decide whether to send it to a microservice or send it to your monolith. So long as you have control over where the request is going once the mobile client or the web client asks for it, you can then do whatever you want, right? You can have half your endpoints still be on a monolith, have the other ones slowly migrate over to RPC. You can have them all on RPC. You can kind of do whatever, right? At the end of the day, for the client that the user is going to use is just going to be using REST still.
I see. That's how DoorDash did it for this migration. We have a gateway in between.
That's right, yeah. And using gateways is great because then you can call a bunch of different services if you need to, and then kind of finalize the result before it gets to the client. So think of like you can set up a gateway server for your gRPC stuff very similar to the way that you would set up like a GraphQL server, right? Only unlike the GraphQL server, the actual work is going to be done on your microservices. And then you can, the gateway is just a way to direct the user to the particular microservice, and you can send it through a load balancer, whatever you need to for scaling purposes.
I see. Thanks.
In fact, for web, if you have like a web front end, there's nothing stopping you from having GraphQL be the way that your web client gets the data from the gateway, and then for your gateway to be serving that GraphQL by calling gRPC on the back end.
Yeah, that's true. All right. Any other questions? Have you come up with any like the downside of using gRPC and Protobuf? Any gotcha?
I mean, gotchas. I mean, it's more stuff to learn, right? At first, it can be a little bit confusing, and when you have really complicated protos, like there is something to be said for the fact that since protos are meant to be self-documenting, right? The protos are human readable. You can see what the types are, but if you're not careful, you can have duplicate work across services. That's something that can happen that you want to try to avoid, right? Because let's say that your service and another service implements the same thing twice in separate proto files. If there are use cases where we need to call both of those services and have access to that object that's been duplicated, those types are going to be different types when you use them on a client, even if they shouldn't be. So that's something that can happen. That's something to kind of watch out for. It's important to what you do is you can set up common protos that you can share across your services, and then you can have specific ones that are pertaining, specifically to one service. So for things like phone numbers or email addresses, something that you're going to use in a bunch of different services, maybe in different ways, or timestamps are one that there's a common proto from Google for example. So anything that's going to be common that you're going to use as like a first class thing in different services, you want to make sure that you have the same proto definition for them that you're referencing. Otherwise, the Codegen will create separate classes, and then you're going to have to create like a wrapper between them or something, or stuff can get messy there. And then regarding starting a gateway, you could the nice thing about Protobuf, you can use anything. I mean, you could use the same framework you were using for your monolith and now just use it for your gateway, right? You just need some way to serve requests to your end user clients, but then on the back end call your microservices. So you can use a GraphQL as your gateway for a web application. You could use Django or Express or Ruby or whatever you'd like to use. The important thing is just that you've got one place that your end user clients know to send requests to. and they don't care about where that work is being done, right? And then from there, to do the actual work, you can send that to gRPC.
Nice.
Most usage of the communication front end, back, and store REST. I think there's a couple things. I think it just didn't support it out of the box. Like, I don't know if there are plans to support it. I would take a look at the roadmap for gRPC if there's official plans to support like proper end user client support. I think when it was coming out, like when they developed it in 2016, I don't think most browsers had HTTP2 support at the time. So part of it's that. But the other part is the reason why I might hesitate to use it on like a mobile client is because of that Codegen. Codegen is a lot more. Codegen is a lot more like palatable when you can spin up your service or update it or redeploy it whenever you want. So if something changes, you can spin up and you want to generate the code and you're fine. But if you're using it on clients, for mobile clients at least, that's code that gets distributed by someone else. And if you change a proto on the back end and you're expecting all the clients to be updated, now you've got to worry about potentially old client versions. If they're breaking changes, you have to worry about just all the stuff that comes with code generation. gRPC via Quick. I haven't seen what Quick is. What's Quick?
Quick is what Google used before HTTP2 became standard. It was kind of like in development, and it was in the Chrome browsers and a few other things way back when. Now that HTTP2 exists, Quick is obsolete, but yeah.
Got it. That would make sense.
I thought it's also probably will be the base for HTTP3. Quick.
Yeah, I think so. I think actually some things like a Duo and all that, even now, like use gRPC over Quick, but I'm not really sure about that.
Interesting, yeah. It's worth looking into. It's worth looking into. It could be cool. Yeah, it would be like it would be interesting if some of that stuff could work dynamically. I mean, there's dynamic code generation on Node, for example. You point it to the proto files and it's able to just do that. It's just a lot easier on the back end when you can spin things up and down as you want, as opposed to a client where you have to worry about it being having to go through approval processes or having to worry about not being able to fix backwards compatibility very quickly. Within your own domain, even if you make a breaking change, you can just, it sucks, but you can change all your clients and spin them up on your own time. As opposed to, when a version of your mobile app is out there, it's out there, right? Unless you somehow force everyone to upgrade. So if you make a not backwards compatible change and you're relying on code generated from an old version of your protocol buffers, then you're just going to have broken clients out in the wild, and that's not fun. And then you might have to end up going and like versioning your RPCs, which is kind of what we're trying to avoid. And that's same issue that I had with GraphQL on mobile clients. At some point, if you use Codegen on mobile clients, you're just going to have to start versioning your APIs again the same way as you did with REST. Got it.
So when you talk about gRPC and Protobuf, it sounds like though around the microservice architecture. And if I'm a small company and we don't have a microservice yet, do you still suggest give gRPC a try?
I mean, if you want to flirt with the idea of microservices, gRPC is a good way to just start trying it out, right? It doesn't force you to completely switch away from REST. It's just a way for your server to make a new type of call, right? So if you want to start a small, microservice that talks to your monolith, that's a great way to start flirting with the idea of microservices. And it gives you the ability to scale something separately and still talk to it very quickly, and treat it like it's just sending you objects natively into your code. So it's there's no reason not to start messing around with it. And the monolith problem is going to happen when you get big enough. So preparing for it ahead of time is cool. There is something to be said about now you've got to manage, these generated client versions, and so that is some extra work that you're going to do. And if it's worth, if you judge that future proofing is worthwhile, if you expect like we're going to get a ton of users soon, and by the time that happens, we should be ready, that could be a worthwhile thing to do.
Nice, well said. Yeah, I think that makes a lot of sense. All right, any other questions? Yeah, if no further questions, probably we can end the events today. Sam, do you have questions for audience?
No, I think there's a networking thing, right?
Yeah. We will just like randomly talk, and if you, basically our event is already finished, and if you want to stay longer, talk with our speakers, feel free to do so.
Sure.